Yeah, audio, video, everything clear. Yes, Shweta, good afternoon. Okay, so let's get started. So this is Venn diagram, okay, and syllogism. Now, first we'll be dealing with Venn diagrams. Now, in Venn diagrams, we mainly see three kinds of questions. One that are related to two variables. So basically what they will give you things about two things. For example, let's say English and Hindi. Okay, now here what you'll have to do, something like they will tell you about a group of people who speak Hindi, or a group of people who speak English, and then they will give you some intersection like that. Then there are some minimum maximum problems in which they tell you that what will be the maximum number of people who are speaking English. So some conditions they will give. Okay, then there are three variables. So instead of those two variables like English, Hindi I took, let's say you have Telugu also. So English, Hindi, Telugu. These are the three languages. Then you will have what? You will have three circles like this. Here you have two circles. That's the only difference. So the main point is understanding this part, which is how you deal with two variables as such. Now, first thing, okay, so let's say there are two things like this. Okay, now let's say this is a class, and this is a class, and this class has 100 students. Now if this class has 100 students, first thing that you should write 100 here, right on the outside. This is the number of people who are enrolled for the classes. Okay, now of course all of them won't be coming to the classes, so some of them that don't come to the classes, you just remove them. So let's say 10 people, 10 people, these are 10 useless people who are not in the class, or who are just not available. So these we'll have to remove. Now this may be about class or anything. So now 100 people were there, 10 people are not in the class, so this you will have to exclude. Now you write the figure that is inside it. Now from 100, if you remove 10, then it becomes 90. Correct? So this diagram that you see, this round thing, okay, this actually represents 90 people only. Okay, now if this represents 90 people, now understand how you write this. For example, let's say in class I throw a party. Okay, so I say that there are two things available, samosa or vada. Now I make a rule that you can either have samosa or vada. These are the only two options. So let's say this is samosa and this is vada. Now what I said, I said that you should be taking either samosa or vada. Now when I started counting after the party, then 70 samosas and 50 vadas were consumed. What does this mean? Now You do understand this intuitively also, that 70 plus 50. Now, if it were an ideal scenario, if all the students in the class were obedient, then the number of people who had samosa and the number of people who had vada should have been equal to total number of students, that is 90. Correct? It should have been the case, but that is not the case. Why? Because very clearly, if you add number of people who had samosas and vada, so this is 70 plus 50, this is 120. Correct? So 120 people is coming as the sum of samosas and vadas, while ideally it should have been 90 if nobody was eating both of these. Correct? Correct? So this intersection actually represents those people who had samosa as well as vada. Okay, so now I subtract this, so 120 minus 90, this becomes 30. Correct? Now I write this 30 here. Why here? Because these are the 30 people that had both of these. That's why you got the discrepancies. Now, once you write this 30, now see this. If this whole figure, this round is 70, this is 30, then what is this? This is 40. Similarly, if this whole round thing is 50, this is 30, then what is this? This is 20. Correct? You understand this? So 40, 30, 20 is what you will get. Yes, Abhishek. Hello. Okay, so 40, 30, 20. Now, what does these numbers represent? So understand that number inside an area represents the closest enclosure. What does this mean? Closest enclosure as in the number that I am writing here. For example, I wrote 30 here. So 30 represents the closest enclosure, that is this part is represented by 30. Similarly, if you look here, so then 40 represents what? 40 represents this crescent shaped figure. Similarly, 20 represents this. Never get confused. Whatever is the closest enclosure is what that number represents. Understood? Now, what does all these values mean? So what are these people? These 20 are people who had obedient and had only vada. Then these are the people who had only samosa, and these are the people who had both. Correct? This you understand? This is both. This is only samosa, only vada, and from this you intuitively understand that I have to calculate with respect to 90 only. 10 people didn't come, so of course they are not represented in the diagram. From this 90, I can, if the question was how many people ate both samosa and vada, now you can do it very intuitively. So you see 90 here. Now you add these two figures. So 70 plus 50 is very clearly 120. 120 minus 90 is 30. These 30 must be the people who had both. Correct? So this becomes 30. This is how you do this. Then if you understand this only, you can do some questions from PYQs by just this basic logic. Let's get started. Now, this is the question. In a group of 15 people, okay, 7 can read French, 8 can read English, 3 can read neither. The number of people who can read exactly one language is. This is the question. What it says, 15 people are there, 7 can read French. Okay, so now I am drawing the diagram. 7 can read French, 8 can read English, 3 can read neither. First thing, I make a box. How many people are there? First thing what we write, total people in the class, group, whatever. So how many people are there in total? In total there are 15 people. Correct? Now, of these, it says 3 can read neither. So they cannot read French or English. So these are the 3 useless people. So you subtract these 3 useless people. Then what you will get here? You will get 12 here. Now, whatever diagram I draw will be equivalent to this 12. This you get. Then there are 2 circles like this. Now, one is of course for French and the other is for English. Now, how many French? So 7 people can read French. So F is equals to 7. How many can read English? So English can be read by 8 people. So 7 and 8 is what you get. Correct? 7 and 8. Now, if I ask you how many people can speak both the languages, same process, correct? Total should have been 12, but 7 plus 8 is 15. So whatever is the difference is equivalent to this common area. So what you get? 7 plus 8, this is 15. 15 minus 12, what you get? 3. So 3 people speak both the languages. Okay. Now, so you get 3 here. Now if you get 3 here, this whole is 7. 7 minus 3, this becomes 4. This whole is 8. This whole is 8. 8 minus 3, this becomes 5. Understood? Simple. Now, the question is asking you the number of people who can read exactly one language. Exactly one language. This is 2 languages, exactly one. This is only French. And this is only English. So what you can do? Simply 4 plus 5 is equals to 9. So 9 becomes the answer. Yes, Dheeraj. Yes, Shweta. Understood? Very simple. What you had to do? You just had to write this in proper diagrammatic form and you will see the answer immediately. Okay, then let's do another. Fast. 19 boys play hockey. Of these, 11 wear hockey shirts, 14 wear hockey pants. There are no boys without shirts and pants. Okay, so there are no naked boys. Something they must be wearing. Okay, what is the number of boys wearing full uniform? Good afternoon. 19 boys who play hockey. Of these, 11 wear hockey shirts, 14 wear hockey pants. There are no boys that don't have either shirts or pants. Okay, full uniform wearing people you need to tell. So now, first thing, 19 boys play hockey. Okay, so this is the total number. 19 play hockey. Now it says that there are no boys who do not wear either shirts or pants. So there are no naked boys. So basically, you don't have to subtract anything. So you get here the same 19. You get the same 19 here. That means the diagram will represent 19 people. Now, hockey shirts, hockey pant, or you can simply write shirts and pants. So this is shirts and this is pants. Now, how many people are wearing shirts? 11 are wearing shirts. And how many are wearing pants? 14 are wearing pants. So 11, 14, 19. Now you know very easily how you find the middle number, which is the intersection of all of both of them. You add these two, that is 11 plus 14, which comes out to be 25. But this 25, why you are getting 25? Because there is some intersection, correct? So what is that intersection? 25 minus this figure, that is 19. 25 minus 19 is 6. So here you get 6. This closest enclosure, this you see here, this actually is represented by 6. Okay, then yeah, okay, fine. Yeah. So let's continue. So number of people who are wearing both is C. Then next, of 130 students appearing in an exam, 62 failed in English, 52 failed in mathematics, 24 failed in both. The number of students who passed finally. Find this out. Yes, Dheeraj. 130 students, 62 failed in English, 52 failed in mathematics, 24 failed in both English and mathematics. The number of students who passed finally. Okay, now what you can do, you can just draw diagram like this. Now total students is what? 130, correct? 130 students are appearing in an examination. Then now the ideal way can be that you draw a failure diagram. Why? Because all the figures are given with respect to failure. These many failed in English, these many failed in mathematics, these many failed in both. So what you can do, you draw a failure diagram. So here by E, what is represented? By E I am representing people who failed in English. By M I am representing people who failed in mathematics. So now how many people failed in English? 62 failed in English. Then in mathematics 52 failed. Correct. So 52 failed in mathematics. Fine. Now 24 failed in both of these. So that means this figure is what? This is 24. Now if this is 24, if this is 24, then this whole is this whole thing is 62, correct? This whole thing is 62. Then what is this? What is this? Okay. Either you can find these two values also, or a much smarter way will be eventually what you get from here, the sum of both. When you take its difference from here, it gives you this middle number 24, correct? So you can do the reverse also, that is you add them both. So 62 plus 52, this becomes 4, 6 plus 5, 11, 114. 114 is the sum here, but the intersection, if you subtract, you get the total numbers that this figure represents. So what you have to do, 114 minus 24, 4 and 4 0, and this becomes 11 minus 2, 90. So what you got here? You got here 90. Correct? Now, if you got 90, now they are not useless people because this is a failure diagram. So 30 and 90, what is the difference? 40. So 40 people are not in the failure diagram. That means what they have done? They have passed the exam. So it is asking the number of students who passed finally, that becomes 40. Understood? If you wanted, you can find these values also. So 52 and 24, what is the difference? So it is 26 plus 2, that is 28. Then if you wanted to find out this, so 62 will be what? 10 more, it is 38. If you add them, 38, 24, 28, that also comes out to be 90. Another way. Okay. Yes, Shweta, correct. Yes, Dheeraj, correct. Then, so understood, two variables is very easy. You just have to draw the diagram, you will get the answer. Just do this one also. This is 2024. Again, I would suggest draw failure diagram. Again, I am drawing a failure diagram. So in Hindi, this is English. In Hindi, it is said that 80% of the students passed in English. That means how many failed? That means 20% failed. Now, one thing is there, if you see the entire question is in percentage, the options are also in percentage, you can very safely assume that the total number of students is 100. Then you don't have to deal with percentage. correct? Because in 100, 20% is what? 20, 80% is what? 80. So you just take total number of students to be 100 and then solve. So now 20 students actually failed in English. So this becomes equivalent to 20. Then in Hindi, 70% passed in Hindi. So how many failed? 30% failed. So that means Hindi is equals to 30. Now 15% failed in both the subjects. So what you have to write here? 15 here. So you write 15 here. 15 failed in both the subjects. This is a failure diagram. Then what is the percentage of students who failed only in one subject? Fairly easy, correct? There are no students who have not given the exam, this, that. So this is 100. So this is also 100, correct? Now, if this whole is 30, this is 15, then what is this? This is also 15. If this whole is 20, this is 15, this is 5. Now, number of students who failed only in one subject is this and this, which is 15 plus 5 is equals to 20, or in other words 20%. So answer becomes B, 20%. Yes, Dheeraj, correct. Yes, Shweta, correct. Then now we go to maxima minima. Okay, now for maxima minima we have to learn a method called stacking method. Okay, this works very well even for more typical questions. So right now what we have seen in UPSC are little easier questions from maxima minima, but learn this method. This is the method that is used throughout. Okay, whenever you have to solve maxima minima questions in Venn diagram. Okay, now let's see how it works using this example only. So it says in a group, one of 120 persons, 80 are Indians and rest are foreigners. Correct? So now just observe carefully what I am doing. 120 persons are there in total, 80 are Indians, rest are foreigners. Rest means what? Rest means what? Very clearly, 40 are foreigners, 80 Indians, 40 foreigners. Correct? Now look here. So basically I draw this. This is Indian is equals to 80. Fine. Then I also draw foreigners. So let's draw 40 foreigners also. So this is foreigners is equals to 40. This is fine. Is this the whole diagram? Correct. This is 120. This is the total number of people. Correct. Now see how we do it further. So further it says, further 70% can speak English. The number of Indians who can speak English is, so we can actually find the complete range. Now 70 people can speak English. What I will do with English is I will start assigning English from both the extreme ends. Okay, so now I start from here. I have to provide 70 people who speak English. So I start from this end. Okay, now I see 40 is completed. Then I have to go more, correct? Because I have to go till 70. So basically here what I get is 40 and here what I get is 30, because ultimately this whole sum of this stack has to be 40 plus 30, 70, correct? Now I start from this end. From this end I start. I only has to go to till 70. So I won't cross this I, correct? You can feel this. So here also I get to 70. Now if you look at this diagram, what do you see? Forget this, forget foreigners. What do you see in Indians? In Indians who can speak English, what is the range? It is at least 30, correct? It is between 30 and 70. So between 30 and 70. That is, minimum number of Indians who can speak English is 30. Maximum number of Indians who can speak English is 70. And somewhere in the range is all the values. Now it is asking you the number of Indians who can speak English is, very clearly, what is this? 20? No. 30? No. 30 or less? No. 30 or more. 30 or more Indians can speak English. 20? 20? Why 20? No. Okay, so 30 or more. 20 all. The question, last question's answer. Okay, now, so answer is D, that is 30 or more. Understood? Now, this is the way that we do stacking. Let's do another. Now, it says out of 120 applicants for a post, 70 are male and 80 have a driver's license. Okay. Then, what is the ratio between minimum to maximum number of males having driving license? So, first thing, what you get? There are 120 applicants, correct? Now, 70 are male. That means how many are females? There are only two genders in these questions. Okay. So, number of males is 70. So, number of females will be 50. Or sum has to be 120. This you understand? Now, let's start drawing. So, I draw the males first. So, this is the male I draw. Male is equals to 70, and then I draw females. Females is given as 50. Correct? 70 plus 50 becomes 120. This is fine. Now, there are 120 applicants like this. Now what I have to do? I have to do distribution of 80 driving license. 80 driving license I have to distribute. What I'll do? You know my process now. Okay, so what I'll do? I will start from either ends. So I start from here. I have to go till 80. So I start from here, and this is 50. So I have to go little more. How much more? 30 more. So this is 50. This is 30. I don't write here driving license this that. I do understand that the top and bottom what I draw is for the driving license only. So 50 and 30. Then from here I start. From here I start. Again 80 I have to go. So I have to go beyond 70 and get here. And this is 80. So if I divide it, this has to be 10 and 70. Correct? This is for driving license. This is for driving license. Now you can find the range for any of them. It says the ratio of between minimum to maximum number of males having driving license. So males having driving license. So males having driving license, range is what? 30 to 70. It is asking you to find the ratio between minimum to maximum. So 30 by 70, or answer is 3 to 7. Understood? Yes, Shweta. Yes, Dheeraj. Correct. Okay, simple. Then let's do a better one. Yeah, let's do this. Try this. Try this. First statement is easy, same as we did before. Second, you will have to think a little. Yeah, yeah. Now, let's see this. Okay. So, in a conference, out of 100 participants, 70 are Indians. 70 are Indians means how many are foreigners? Foreigners comes out to be, foreigner comes out to be 30. Easy. Now, I draw. I first draw Indians. Indians is given as 70. Then I draw foreigners. Foreigners is given as 30. Correct? Total 100 participants are done. Now it says if 60 participants are vegetarian, then which of the following is correct? Now I will draw vegetarian people. So one way is drawing. I start from here. I have to go till 60. So I must cross this. 30 will be here and 30 will be here. Correct? This is vegetarian people. Correct? Simple. Then you start from here, draw the same thing. Now I don't have to cross Indians. Why? Because I only have to go till 60. So I go till here, and this becomes directly 60. correct? So now it is asking at least 30 Indian participants are vegetarian. So basic question is about what? Indians who are vegetarian. Vegetarian Indians, can I find the range? Yes, very easily I can find the range. What is the range? Minimum is 30, maximum is 60. Now it is saying at least 30 Indian participants are vegetarian. Yes, at least 30, 30 or more. So answer is this is correct. Then now just slightly you have to think more. So basically now it is telling about Indians who are non-vegetarian. Now see, now see. So Indians who are non-vegetarian. Now how do I find this? Now take the extreme cases. If 60 Indians are vegetarian, how many Indians are non-vegetarian? Tell me this. Total 70 Indians are there. So total Indians is 70. Now 60 are vegetarian. How many are non-vegetarian? 10. Then if 30 are vegetarian, then how many are non-vegetarian? 70 minus 30, 40. Now of course greater than equal to will go in this direction, that is Indians who are non-vegetarians greater than equal to 10 and less than equal to 40. Correct? Simple. So what you get to? At least 10 Indian participants are non-vegetarian. Yes, it is between 10 to 40. So this is also correct. Now I can tell you one more method, but sometimes the diagram seems difficult to students. Okay, so one method is this that you learned. You just have to do it from total Indians and get this. The other is actually, if you go further and start drawing, start drawing the remaining one. See carefully. So if this is 30, if this is 30 of 70, 30 are gone, then what remains? Isn't this 40? Isn't this 40? Correct. Now, if 60 is this, then what is this? This is 10. Correct. What is the range? If this was the diagram for vegetarian, what remains is the non-vegetarian. So non-vegetarian, Indians who are non-vegetarian are in between. From this diagram, Indians who are non-vegetarian are very clearly between 10 and 40. You did this using the remaining diagram, that if 30 Indians are vegetarian, then 40 may be non-vegetarian. If 60 are vegetarian, then 10 may be non-vegetarian. So this is another way of doing the same thing. Both are actually correct. Yes, Dheeraj. Yes, Shweta. Understood? Then okay, so maximum minima, this level only has come. This was the better one that they have given. Just have to draw the diagram, it becomes very easy. Then next we get to three variables. Now three variables is nothing. Okay, it is just same process is there, just some more time you will require. Okay, now here just one thing. Here the closest enclosure thing that I told you becomes more important. So understand this. For example, let's take this question. In a town, 45%, see everything is in percentage. What I can assume? I can assume that the total number of people in the entire village or town, whatever, is 100. That I can assume, correct? Everything is in percentage. Now I draw three circles like this. Okay, now it says what? It says, yeah. Now it says 45% read magazine A. So let's say this is A, this is equals to 45. Then 55% read magazine B. So B is equals to 55. Then 30%, sorry, 40% read magazine C. So C is equals to 40. Correct? 45, 55, 40. Now 30% read A and B. 30% read A and B. Okay. But please wait. What is a good habit? That instead of these two, try to find out the place where there is most intersection and value of that. Now in two variables also, what you were doing, you were finding the value of the intersection first. So first target should be to fill this. Then it becomes easier. So just search in the question. Is that given? Yes. 10% read all three. So first you should fill what? You should fill this. So here it becomes 10. Once this becomes 10, now it is easy. Now it says 30% read A and B. See this carefully. 30% read A and B means what? What is the region that reads A and B? This is not the region. This whole thing is the region. Can you feel this? This whole is the intersection of A and B. Correct? Now, according to the question, 30, this whole intersection represents 30 people. But 10 people are already gone in the closest enclosure of all three intersections. So if this whole is 30, this is 10. What is this? This is 20. Please do remember, you will only fill 20 here, not 30. Don't get confused. That's why what we fill first, we fill the all intersection first. So now you get 20. If you understand this, then everything else is very easy. 15% read B and C. So this is B, this is C. 15%. So this whole is 50. This is 10. Then this is 5. Then next is 25% read A and C. So this whole is 25. This is 10. Then this is 50. Now it is asking you what percentage do not read any magazine. For this, you need to find more figures. So now see, 20 plus 10, 30. 30 plus 15, 45. So what is this value? This whole circle represented 45. Now 45 is already taken. 20 plus 30, 20 plus 10, 30. 30 plus 15 is 45. So this is actually 0. Does not matter. Don't be scared. It's fine. It comes out like this. Then 20 plus 10 is 30. 30 plus 5 is 35. This whole is 55. So this is what? 55 minus 35, that is 20. Then 15 plus 5 is 20. 20 plus 10 is 30. 40 minus 30 comes out to be 10. Now this blank you have to fill. This blank is equal to what? Whatever numbers are filled inside, not the outside ones. This is what the diagram represents. Because here you don't have any overlapping. You only have counted the people who are intersecting all three. You have only counted them once in this 10, correct? Otherwise you're not counting them. Then let's add them. So 20 plus 20 is 60. This is also 20. 20 plus 10, this is 30. So 40 plus 30 is 70. 70 plus 10 is 80. Correct? 20 plus 20, 40. 40 plus 20, 60. 60 plus 10, 70. 70 plus 10, 80. So now it is asking you the percentage of people who do not read any magazine. That is, it is asking you about the useless people. Total people were 100. 80 are reading at least some magazine. So that means the difference is what? 20. These are the 20 useless people who don't read any magazine. Understood? So answer becomes C, 20%. Yes, Shweta. Correct. Understood? Simple. Just follow the process. It is little lengthier than the two variable one, of course, but otherwise it's easy only. Okay, then let's do another. Yeah. In a group of persons traveling in a bus, 6 can speak Tamil, 15 can speak Hindi, 6 can speak Gujarati, none can speak any other language. Now, why this line is important? Because if I'm making a big box like this, then whatever is the number of people, total number of people, same will be the, this both will be exactly same. Because it very clearly says none can speak any other language. So there is nobody who is outside the diagram. That is why this sentence is given. If 2 persons speak 2 languages only and 1 person speaks all 3, how many persons are there in the group? Okay, now let's make them. Now let's see. So first thing is 6 can speak Tamil. So this is Tamil, this is 6. Then 15 can speak Hindi. So this is Hindi, this is 15. Then 6 can speak Gujarati. This is Gujarati, this is 6. Now it says none can speak any other language. That is fine. If 2 persons speaks 2 languages only, 2 persons speaks 2 languages only. Okay. But first thing, what we search for? who speak all three, that is at the intersection of all three, and one person speaks all three. What is this? This is one. Okay, this we have already got. Now it says there are only two people who speak two languages only. Okay, very specifically, they don't speak two languages only, means very specifically two only. It does not mean that they may speak the third also, they may not speak no, they speak two languages only. Now which part represents two languages only? This only two languages, Tamil and Hindi. This only two languages, Tamil and Gujarati. This only two languages, Gujarati and Hindi. They don't speak the third language, and this is what we were searching for. So it says there are two such people. Now if there are two such people, how do you fill it? You can fill it in any way. The question does not define it. Why? Because ultimately the question only cares for this number. Correct? So any way you like, you can fill it. You can fill it like, for example, let's say I fill it like 2 0 2 0 0. This is one of the possible arrangement, or I can fill 1 1 0. Ultimately the sum should be 2. Correct? I can fill it 1 1 0 or 1 1 0, does not matter. Ultimate sum will be exactly same. So I just choose this arrangement, and now let's find out. So this is 2 plus 1 3. This whole thing is 6, so this is of course 3. Then 2 plus 1 is 3. This whole thing is 15. So 15 minus 3 is 12. Then this whole thing is 6. This is 1. 0 0 does not matter. 6 minus 1, this is 5. Now how many people are there in total? Very clearly, 12, 3 plus 2 is 5, 5 plus 12 is 17, 17 plus 1 is 18, 18 plus 5 is 18 plus 5 is 23. So how many people are there in the group? Group has 23 people. Yes, Shweta, correct. A, no Dheeraj, not A. Okay, understood? Okay, then similar are these questions as well. Okay, this is even more like much easier in concept, just some calculation. So these two you can take as homework. Oh sorry, this you can take as homework. Only one was left. Understood? Now let's get started with the second part, which is syllogism. Please do the homework. Okay, two questions I gave you in the last class, one I gave you today. Okay, please do them. Now this is syllogism. Now first thing, what you see, all A are B. This is a normal diagram. This you might understand. All A are B. So I have drawn A inside B. This you understand. Then some A are B. So I have drawn A and B with some intersection. Fine. Then no A is B. So I have drawn A and B separately so that they have nothing in common. Then some A are not B. Now some people get confused here. See, some A are not B. I only have to ensure one thing, that there must exist some A which are not B. I don't care about others. I just want very little, some 1, 2, whatever A, that should not be B. That is the only requirement of this sentence. So do I have some A which are not B? Yes. This part of A is not B. So this is the diagram for some A are not B also. Okay, now. So all A are B. This is fine. Now some A or B also has another diagram. See this. The question says, the statement says what? There are some A's in the world who are B. Okay, like there are some intelligent people in the world who are rich. There are some intelligent people in the world who are rich. Now, if I say that, why you are saying some? In fact, all intelligent people are rich. Correct? So does this violate this condition? No, it still satisfies. What I told you is there must be some intelligent people who are rich. If all of them are rich, very good for them. Okay, so here Another diagram that is possible is this: A being contained entirely inside B. Now some A are B, yes, some A are B, correct? This is also possible. Now this is also a possible diagram, correct? Here also you can see some of the A's are B, correct? Some A's are B here also, both are possible. Now some A are not B. Now this can also be drawn as A not being B. Why this is also possible? Because it only talks about A not being B. Now if no A is B, that also is fine with me. Understood? So please remember these diagrams also. Sometimes they are used. Mostly this will be it. If you can remember this, you will be done. But in some questions you may have to see for them also. But usually if the question is some pens are dogs, then you draw it like this only. Don't think much. Just draw it like this, solve it, no problem will occur. In some very good questions you might face some problem, but those becomes very obvious that this is a question like that. There you have to see the other diagrams as well. Okay, then one more diagram for all A or B is also A and B being equal, but that is too obvious. If A and B are equal, that was also fine, all A or B. Then now see this. Statements can be of two types. Okay, one is absolute statement that must hold in every diagram. Okay, for example, absolute example: all boys are dumb. Let's say I say this. Now is this an absolute statement? Yes. Now for this to be true, it must be true that all boys are dumb, even if I can find one case where that particular boy is not dumb. Okay, let's say Dheeraj is not dumb, then this statement becomes incorrect. Okay, so here in absolute statement, whatever diagrams we draw, if it is not satisfying even in one diagram, that is gone, that is wrong. It must hold in every diagram. Then there is can be or maybe kind of statements. These are also called possibility statement, but people get confused. So can be, maybe, sometimes may not be also. So ultimately this is maybe only negative form. Now here if it holds even in one diagram, then it is fine. So I say some boys can be smart. Now for this to be correct, what do I need? I just need one boy. If that one boy is smart, then I am done, correct? To negate this, it becomes very difficult. So here even if I get one boy, it is fine, correct? So may or may not be. If it holds only in one diagram, then also it is correct, considered correct. Now this we'll see while doing the questions how you deal with it. Okay, now let's get to a question. 1 2 I'll solve, then you will get in the flow. Now let's do this. Okay, now all dogs are cats. How you will dot this? So this is cats, then all, sorry, yeah, it was correct only. All cats are dogs. Okay, so this is cats. Now all cats are dogs. This is fine, correct? The usual diagram, all cats are dogs, correct? Now all cats are black. All cats are black. Now how do I draw black? See, there are two possibilities now. All cats are black, all dogs are black, all cats are black. Now I may have black here. This is one possibility, I'm saying it B1. Or all cats are black, so I may also have a very big circle like this. Let's draw even bigger like this. This is also a possibility now. Very clearly all cats are black, correct? Here also all cats are black. Now, but why these are two different diagrams? Because in the one of them, B1 is inside D, that is dog, and in the other one, B2 is, in the other one, D is actually inside B2. So that's why they are very different scenarios. And this is what we know as relation between A, B and C. Now see this term. So basically why you got two diagrams, understand this. So some relation between A and B is given to you, some relation between B and C is given to you. Then, so they are talking about A and B, then they are talking about B and C. Are they talking about A and C? No. No statement is talking about A and C. So A and C can have two kinds of relation. One where they have an intersection and the other where they don't have an intersection. So you can remember it like A and C will have two possibilities. Now all cats are black, so this is like A, let's call this A and B, this becomes B and C, correct? A and B, B and C. Now what is the relation between A and C? Correct, it will have two possibilities. One possibility is A is contained inside C, in this case because it is all case, or C is contained inside. So there will always be two possibilities like this. That's why you have to draw the two diagrams. Just remember this. You will see that in every question almost we will use this. Now let's get to the conclusions. All dogs are black. All dogs are black. Now according to B1 it is not satisfying. What are these? This is an absolute statement. 99% of the questions that you get will be absolute statement. You don't even have to worry. Nothing you have to do. If it does not satisfy in any one diagram, just cancel the statement. Very rarely, only once we have seen a maybe kind of question, and that you can very easily check out. Otherwise, it's just absolute statement. Find one diagram where it is not satisfying, cancel it immediately. That's the process. So now all dogs are black. Now all dogs are black, not holding in this diagram, correct? Here you have dogs that are not black, so this is wrong. Then some dogs are not black, some dogs are not black. Now according to B1 this is correct, some dogs are not black, but according to B2 is there any dog that is not black? No, correct, all dogs are actually contained in this. So all dogs are black, so this also is not possible. Answer becomes neither. Okay, then let's do one more. Yeah, some greens are blues. Okay, so some greens, so this is greens, are blues. Then some blues are blacks. Now let me draw blacks. Now again you remember this, this is A, B, B, C, correct? This is not known. This you can see, sorry, let's write this in the same form. A, B, then A, C, correct? Yeah, so basically here AB has a relation, AC has a relation. What does not have a very clear relation? B and C. So again there will be two possible diagrams. So what you do, you have drawn green and blues, you have drawn. Now you have to draw blue and black. So one possibility is that G and black does not intersect. This becomes black, correct? This is the first possibility. The second possibility is when green and black also intersects, correct? So with blue it has to intersect, that I am ensuring, but I am also intersecting it with G, that is green, and this is the second possibility. Understood? This is the first, this is the second. Both diagrams you have. Now see all the statements, they are all absolute statement, so just find out if they are correct in for both of them, otherwise they are wrong. Now some greens are black, some, see I'm just writing here only now, according to diagram 1, diagram 2, what you have. So according to this diagram, what you have, some greens are black, yes, some greens are black, no. What is the final result? No. What is the final result? One in one U this is correct, in the other it is not correct. Ultimately it should be correct in every diagram, so this is wrong. Then No green is black. No green is black. But according to this, there are some greens, correct, which are black. Cancel it immediately. Then all greens are black, not holding in this or the other diagram also. Then all blacks are green. All blacks are green, not holding this diagram. Correct. This also becomes wrong. Again, the answer is none. This is how you have to do. Once you have drawn A, B, then the C that you draw will have two possibilities. That is the relation that it has with A. One time you have to intersect it, overlap it, or the other time you just keep it separate. Fine, everyone. Now, you do one. Some radios are mobile, all mobiles are computers, some computers are watches. Do this then. Certainly some radios are watches, certainly some mobiles are watches. Now, this certainly is not even needed. This is also an absolute statement anyway, that some radios are watches, some mobiles are watches. Certainly is just they wanted to put some words, so they put. Try to do this. Try this same process. Okay, so some radios are mobile, some radios are mobiles. Then all mobiles are computers. Okay, so I draw all mobiles mean all mobiles are computers. Fine. Then now next, some computers are watches. Now, do you think there will be one diagram or two diagram? Some computers are watches. Now, there are again two possibilities, correct? One is I draw watches very separate, just intersecting with the computer. So this becomes what? So this becomes watches, correct? This is the first diagram that is possible, correct? Some computers are watches. Now, another diagram that is possible is let me intersect this watch with everything else also. Who's stopping me? So I draw watch like this. This is the second possible diagram, correct? I'm not violating any rules that is given here, correct? Then some radios are watches. Some radios are watches, correct, according to this, but not according to this, correct? Here some radios are not watches, so wrong. Some mobiles are watches. Now some mobiles are watches. Now some mobiles are watches. Now if you look at mobile and watches, now here if you look, it is correct, but here it is not necessarily correct. Ultimately some computers are watches, correct, and all mobiles are computers. So there may be certain computers that are not mobiles and intersecting with the watches. So again, some mobiles are watches is also not holding in this diagram. So this is also wrong. Answer becomes D, neither. Okay, got it. That's why I draw a diagram like this, where C is much bigger. Okay. Then next, do this. Some rats are cats. Rat, cat. Some rats are cats. Some cats are dogs. So some cats are dogs. Now, dogs, I have two possibilities. Dogs and dogs. This is D1, this is D2. Then No dog is a cow. No dog is a cow. How do I draw this? No dog is a cow. Now either I can draw cow very shyly, okay, being very shy, that I draw cow very separate. No dog is a cow, this is holding. The other way can be, I can see no dog is a cow, that means dog and cow don't have an intersection, but there is no restriction on R and C, so I can have a cow here. So this is cow 1, this is cow 2. Okay, so these are the diagrams that are possible. No dog is a cow is also done. Now no cow is a cat. Is this correct? Is this correct? No cow is a cat, but here I have some cows that are cats. First is wrong. No dog is a rat. So no dog is a rat. No dog is a rat, but here I have some dogs that are rats. Correct? This is also wrong. Some cats are rats. Is this correct? Yes, some cats are definitely rats. This you can get from here also, because some rats are cats, so then some cats are also rats. Also, if you see the diagram, there was no other diagram possible for rat and cat. Correct? So of course there are some rats that are cats, or some cats that are rats. So third is actually correct. Answer becomes C, that is only 3. Yes, Shweta? In such cases mostly we. Okay, understood? Simple. So you have to draw a diagram. Just think about this thing AB, BC, then AC can have two things. One is it will intersect with others, and the other is it won't intersect with others. This is it. Then let's do another. So all pens are books. No chair is a pen. Then all these are conclusions are given. So all pens, so this is pen. All pens are books. Very nice. Then no chair is a pen. Now, no chair is a pen. How can I draw? So one possibility is I can draw it separate from the entire world. You can draw chair here. So no chair is a pen. The other thing, again, that same possibility, that I know the relation between pen and chair, but not between book and chair. So this is, let's say, C1. Then another is possible, that is C2, which intersects with the book, of course not with the pen. So these are the two possible diagrams. Now all chairs are books, of course not holding in any diagram. Then some chairs are pen, some chairs are pen. Now this is not possible. Why? Because no chair is a pen. So some chair being pen, no, not possible. All books are chairs. All books are of course not chairs, not holding in any diagram. No chair is a book. No chair is a book. This is fine here, but here I have some chairs which are books. So this is also wrong. No chair is a book is also wrong. Answer again becomes D, none. Yes, 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 Shweta. In most questions you get none, but please don't make it a rule. Okay, that I will just mark none. That should not happen. But yeah, most cases you are able to reject it. Okay, if you see the diagrams carefully. I have not seen a question where they will give like all of these. That they don't give. So some you have to eliminate. Mostly, most of the statements get eliminated. But we have seen questions where they don't. For example, this. See, only 3 follows. Okay, so there are questions like these also. Then now this is a me kind of question. Okay, see, some cats are almiras. So this is cat, this is almira. Fine. Some almiras are chairs. Now again I will have two possibilities. Chair, once I will draw like this, once I will draw like this. This is chair 1, this is chair 2. Correct? Now some cats are almiras, some almiras are chairs. This is done, this is done. Then all chairs are tables. Now here all chairs are table I have to draw. So now all chairs are tables. So I draw it like this. This is a table and also this is a table. Fine, does not matter. All chairs are table. Now certainly some almiras are tables. What do you think? Certainly some almirahs are table. Is this true here? Yes. Is this true here? Yes. In both the cases it is holding, of course, because all chairs are almirahs and chairs are contained within table, or you can see by both the diagrams it is holding. So certainly some almirahs are tables. This is fine. Then some cats may not be chairs. What do you think about this statement? Some cats may not be chairs. Some cats may not be chairs. So this is a maybe, can be, maybe not kind of statement. So here, even if you find one case where this is true, the statement is true. Remember this, correct? So now, can you find me some cats which are not chair? In any diagram, anywhere, can you find me some cats that are not chair? Yes, these are so many cats, see, which are not chairs. So there are many cats which are not chair in both the diagrams. So some cats may not be chair. This is also absolutely correct. Answer becomes both 1 and 2. Yes, Dheeraj. Yes, Shweta. Good, good. Okay, then. Yeah, let's do this. Given that statement 4 is true, what can be definitely concluded? This was a good question. Okay, this is the last question. This you will take as homework, very easy. This is the focus. Given that statement 4 is true, what can be definitely concluded? Now, first of all, the structuring is very different. Okay, how the structuring is different? See this. So, first thing, given that statement 4 is true, what does this mean? This means that what you see as 4, this is actually like the usual statements that you got. So statement becomes some colors are not pleasant. This is the statement. Now conclusions, the other 3 statements are actually conclusions. So just the arrangement is different. So these are the other 3 conclusions. So conclusion 1, conclusion 2, conclusion 3. That is your statement. These are your conclusions. Now let's see. So first thing, some colors are not pleasant. What will it look like? For this question only, we need that diagram that we learned. So some colors are not pleasant. So this is colors. This is not pleasant. This is one diagram possible. Very clearly, some colors are not pleasant, which are lying here. Now, I told you about one more diagram, which was this. You completely draw them separately. Are some colors not pleasant? Yes. In fact, all colors here are not pleasant. Does not matter. I am satisfying the minimum condition given in the question. Now, most people didn't see this diagram and then they got it wrong. Now, let's see this. If these are the 2 possible diagrams, if you see the statements, all, some, no, does not matter. It is not talking about can be, maybe. So these are what? All 3 of them are absolute conclusions or absolute statements. So even if they are wrong in any one of these diagrams, they are wrong. Now let's get started. So all colors are pleasant. All colors are pleasant. This is not holding in any diagram. So of course this is wrong. Correct? Then some colors are pleasant. Some colors are pleasant holding in this diagram, and many people mark this as correct. But this is not holding in this diagram. Some colors are pleasant, not holding there. That's why this is also wrong. Then third, no color is pleasant. No color is pleasant. Now it is holding in this diagram, no color is pleasant, but here you do have colors that are pleasant. So here it does not hold. That's why this is also wrong. Then which of these are true? Now if you see the options, first thing, 1 and 2 are true, wrong. 3 is true, wrong. 2 is false, okay, or 1 is false. Now here comes the turn. Now you look for the statement 1. The statement says, one says all colors are pleasant. Is it wrong here? Yes. All colors are pleasant. Is it wrong here? Yes. Now even with statement 2, even with statement 2 is false, is not a direct conclusion. Okay, what is a definite conclusion? What you can definitely conclude? What you can definitely conclude is only that the first is false. Why? Because 2 may be true, 2 may be true in case of this diagram, but 1 is absolutely wrong in both the diagrams. So only thing that you can definitely conclude with surety is 1 being false. Understood? So this is why this question was little twisted and different. Yes, Dheeraj, correct. Understood why 2 is false is not the correct answer? Because 2 still has two possibilities. It is talking about definitely concluded. Correct? So that's why I eliminated that also. Now first you look at, first has no chance. Both the diagrams, no chance. So 1 is definitely false. Okay, then this is the last question. This you can take as homework. Very easy, nothing much. Some doctor, teacher, all teacher, engineer, all engineer, scientist, and then this. Okay, so that's it for our lecture on Venn diagram and syllogism. If you have any doubts, you can ask. Otherwise, I think we have went a little long. We'll end the session. Okay. Okay, Dheeraj. Okay, Shweta. Okay, if anybody still gets any doubt, sees this video later, you can ask them on the Telegram channel. That's it. Thank you.